Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Wan Azizah binti Wan Mahmud from Electrical Engineering Department, Polytechnic Sultan Azlan Shah, Bihrang, Perak. On behalf of my team, Nur Farah Wahida binti Muhammad Nur and Siti Norazma binti Muhammad, would like to present a proposal for partially paralyzed patient monitoring using the Internet of Things. Introduction. As we all know, paralysis has been declared a common disease and 30% of them are caused by physical trauma regarding COP 2022. However, there is always a limited number of medical officers in a medical center to entertain them since we are facing the constraints of the requirement in medical staff, especially in medication and nursing. Therefore, in this case, we need a monitoring system for paralyzed patients to ensure the essentials can be fulfilled comfortably. For this purpose, we took the initiative to propose this application of IoT with the hope that it will work in medical care industry. Problem statement. Patients who are treated at a medical center always need certain attention. They always need to call for medical officers for any essentials since they have troublesome to move or serve themselves. To get it, they are facing difficulties to make a call to the health officers from their room. Due to these difficulties of paralyzed patients have health officers, they are likely to be neglected for a few moments before it is time to be monitored, and this will cause discomfort for them. Besides, the packed schedule of the doctors and nurses, which is loaded with many patients, also could lead them to overlook if there is a patient who needs serious attention. This condition may threaten life, and the unwanted case also might happen. Project scope and limitation. This project is designed to cater to paralyzed patients who can use hand gestures for communication. The project scope encompasses using wearable sensors to capture gestures which are then transmitted to a centralized platform via smart devices. It leverages IoT technology to enable real-time communication between patients and caregivers. However, the project has limitations, including a reliance on smart gadgets with internet access, the complexity of gestures, network stability, user training, and data security concerns. Despite these challenges, the project exemplifies the fusion of medical science and technology to enhance the lives of paralyzed patients, emphasizing the potential for accessible and personalized healthcare in the future. Project objectives. The project's objectives are focused on harnessing the potential of gesture-based communication to bridge the gap for partially paralyzed patients. The initial objective of the project involves a comprehensive study of the fundamental hand gestures that partially paralyzed patients can employ to convey essential messages. This system is meticulously designed to sense, interpret, and decode the gestures made by partially paralyzed patients. The system innovation is in its ability to convert these gestures into meaningful messages, transcending the limitation that traditional forms of communication might impose on patients with physical impairments. The third objective of the project revolves around the integration of Internet of Things technology to facilitate seamless communication between patients and healthcare officers. Leveraging wearable sensors and smart devices, the system establishes a conduit through which patients' interpreted messages are transmitted to the healthcare team. This real-time connectivity ensures that critical information reaches the right individuals promptly, enabling them to provide timely and appropriate responses. Research method. The flowchart shows that the system is getting the accelerometer ready to detect any tilt of hand gestures. The left tilt will activate the system to send a notification to call for an attendant and followed by displaying the message on the LCD screen. If it does not receive any left tilt signal, it will detect if there is any right tilt. If right tilt is detected, the system will send a notification that the patient needs food and LCD also will display the same message. If no tilt is detected, the LCD will remain displaying no input. And here we have the block diagram shows that the system is developed by using Arduino Uno as the microcontroller unit. The system requires two types of power supply, which is 5 volts and 3.3 volts. The components that operate at 3.3 are sensors, and the sensors generate analog output is connected to analog pin of Arduino's analog pins. Meanwhile, the project is also using a digital sensor, which is the accelerometer gyro. The use of accelerometer gyro sensors is to allow patients to interact with other people through specific gestures. Then, the analog digital data are processed by Arduino based on the program that will be written on it according to the project objectives and gesture setting as the project input. Finally, the output can be seen on LCD display and also being processed by ESP32 Wi-Fi, and the signal will be sending to the mobile of the health officer as the alert for patient condition. Expected findings. Based on this table, there are two gestures of the hand movements that can be detected by accelerometer gyro. These gestures are interpreted by identifying whether the hand is tilted to the left or to the right. To meet the requirements of the system consists of a transmitter and a receiver section. In the transmitter section, at the patient side, a two-axis accelerometer will be placed on the finger of the patient. If the patient tilts hand to the left, it will convey a message that they need an attendant. If right tilt is detected, the system will send a notification that the patient needs some food, and LCD also will display the same message. If no tilt is detected, the LCD will remain displaying no input. For the summary, I can conclude that this project is proposed to help patients getting personalized care for the healthcare officers in a medical center. This monitoring system is implementing the IoT platform so that the messages from patients could be conveyed to the healthcare officers. This proposed project implies a great contribution in medical care industries as it could reduce the workload of the healthcare officers. And last but not least is it also could improve the effectiveness of paralyzed patient treatments by having a personalized monitoring system on each patient. And with that, I end my presentation. Thank you very much.